Welcome to our lesson this evening in section 7.7 from the book. And in this section, we're going to go ahead and tackle two types of word problems that I'll just do in this section. I'm not going to tackle every single type that's presented here, but this should give you a flavor of how to pick out the critical information in a problem and then solve rational equations that we're going to create from a word problem. So we're going to start off with a type of a rate problem here, not a rate, but a problem where we have to calculate some time. I'm going to read the questions. I'm going to tell you that they come from the book. If you want the question to look at, I'll encourage you to go ahead and look up the book as a resource online at the part where I showed you where the chapter contents are. So if you want to see the questions, you may look at them there. I will, in fact, read the questions and discuss each one as I go through them, but I'm not going to write the questions out at length. So, here we go. Question 7 reads as follows. Trey can refinish the floor of an apartment in 8 hours. Matt can refinish the floor in 6 hours. How long will it take them working together to refinish the floor? So, that's a question. So if Trey can do it in 8 hours, Matt can do it in 6, it seems like together they should probably be able to do it in less time. So we're going to set this up in the following way. So we're going to have this fraction here is going to be 1 plus something. We're going to take a look at the amount of time it takes Trey to do this in, which is not 1, but t over 8. And the t is going to be for the amount of time it's going to take both of them to do the job together. So it's going to be t over 8 plus t over 6. And we're going to go ahead and we're going to set that equal to 1. One thing I should mention here too, there'll be a few word problems that will be on the test. If you find word problems to be uncomfortable, it will not make or break you in this course. So I don't want you to feel immense pressure when you're doing these. Try to embrace the challenge and certainly feel free to ask questions. We will go over this in principle in class on Saturday, as you will have seen by the time you see this lesson here. So we have t divided by 8 plus t divided by 6 set equal to 1. Well, as we learned about in section 7.6, we want to get rid of the fractions in this equation. So for 8 and 6, the least common multiple of this is going to be 24. Okay, so we're going to go ahead and multiply this whole fraction through by 24 over 1. What this is going to do for us, and I'm just going to kind of see if I can find another colored pen here, or pencil, so to kind of highlight this 24 over 1. And what I'm going to do is I'm going to distribute 24 over 1 to each part here. So it's going to be 24 over 1 times t over 8 plus 24 over 1 times t over 6 equals 24 over 1 times 1. So we'll go ahead and kind of work that out now, but you can see how the 24 is distributed and how the fractions are going to go ahead and disappear. And we're going to go ahead and see the total time it's going to take Trey and Matt to refurnish the floor together. So, 24 I can rewrite as 8 times 3, so that the 8's reduce, giving me 3t. I can take 24 here and write this as 6 times 4, so the 6 is reduced, giving me 4t. And then 24 times 1 is just going to be equal to 24. So now we have the equation 3t plus 4t is equal to 24. I'm going to go ahead and take 3t plus 4t, combine that to 7t is equal to 24. And if I simply divide that out, divide by 7 to get t by itself, I'm going to get t is equal to 24 over 7. So just a note on this, if you put this answer in my math lab, it may accept it, it may not. It may want kind of like about how many hours, and 24 over 7 won't give you any whole number of hours, even though, yes, it is an improper fraction. So if I convert this improper fraction into a mixed number. I see 7 goes into 24. Let's see, it goes in, let's see, 7, 14, 21. So I can write this as maybe 21 over 7 plus 3 over 7. And we know that 21 over 7, or 21 divided by 7, is equal to 3, and then 3/7 hours. So if it doesn't like the answer as an improper fraction, you can express the answer as a mixed number. Now, this is the answer it provides in the book. Just know that as far for tests and for testing purposes, when you give an answer on my test, I would accept an answer as an improper fraction or a mixed number unless it unless it exactly specifies, which I will not likely do for these type of questions. So I will be perfectly happy with this answer so long as the fraction, improper or proper, is in lowest terms. So let's go ahead to question 9 now. I'll go ahead and read question 9 and give you an idea of what this is going to look like again. So it says the San Paulo Community Swimming Pool can be filled in 12 hours if water enters through a pipe alone, or in 30 hours if water enters through a hose alone. If water is entering through both the pipe and the hose, how long will it take to fill the pool? So similar type of question here. We're looking for the combined time. And the time it takes each of these individual to do is 12 and 30. We're going to go ahead and set that equal to 1. So again, I'm going to try to find the number that's the least common multiple for 12 and 30, which is going to be 60. So I'm going to go ahead, I'm going to separate that out. And again, I'm going to go ahead and put that in red so you can see this more easily. And I will go ahead and distribute that through everything here. So this is going to be 60 over 1 times t over 12 plus 60 over 1 times t divided by 30 is equal to 60 over 1 times 1. And you'll see that the technique for these questions is roughly the same. And in fact, they'll likely show you a very similar technique if you follow the examples online. So let's go ahead and continue with this. So I can write 60 here as 12 times 5. So that the 12 is reduced, leaves me with 5t. Here I can rewrite 60 a little differently as 30 times 2. That way the 30 is reduced, leaving me with plus 2t. And then that's going to be equal to 60 over 1 times 1, which is just 60. So now we have a much simpler equation without fractions now, which is 5t plus 2t equals 60. So 60, 60, not 6t. So this is going to be 7t equals 60. When I combine my like terms, I'm going to go ahead and divide by 7, and then t is going to equal 60 over 7. Again, if you're on a test, I'm okay with that answer. You probably, like in the previous question, you probably do want to indicate the number of hours with HRS. And if the program asks you for this to be put as a mixed number, well, you can go ahead and write this as, let's see, 56 over 7 plus 4 over 7, because 56 plus 4 is 60. Why do I choose this? Because 56 over 7, well, that's equal to 8. And then I would just write that as t equals 8 and 4/7 hours. These are the only two examples I'm going to show for this, because once you see the technique again and again, it gets a little simplified. But I am going to go take a look and take a stab at a few questions that kind of take this principle and flip it on each other. I've seen the explanation in the book. I'm not terribly happy with the explanation of the book. To me, my technique seems to make a whole lot more sense the way I explain it. So pay close attention here, and I'll go through just a couple examples of this as well. So question 13 reads as follows. The AFICO MPC 2500 takes 3 times as long as the MPC 7500 to copy Raghedah's grant proposal. If working together, the two machines can complete the job in 1.5 minutes, how long would it take each machine working alone to copy the proposal? So, in this question, please take time to look at the question online in the book. They give you the number of these machines, which are essentially identifying the name of the machine. just like, for example, if you have an LX470, like a Lexus LX470, or you've got, can't think of names of cars now, or an LX300, or you've got a Chrysler 300, for example. These are just names. The number of the vehicle that's part of the name has no meaning in the problem, and these numbers are what we characterize as distractors in math problems. They have no bearing in the computation themselves. So what numbers are important? It says if working together, the two machines can complete the job in 1.5 minutes. So essentially, in this question for number 13, we have the time that the machine is going to take if they work together. When we're trying to calculate the time that it took if they were working together in the previous problem, we put that as an unknown, or as t. Well, we know that here, so we're going to go ahead and put that here. We don't know exactly what these values are. We know there's a relationship between them, though. And the key thing it tells you is that the AFRICO MPC 2500 takes 3 times as long as the MPC 7500. So we have the AFRICO, let me put that down here, A-F-I-C-I, Officio, I should say, MP, P2C, 2500, and then the other machine we have is the MPC 7500. Okay, again, these are distractors. We know that, what is it? This machine takes 3 times the time that this does. If this takes 10 minutes, this takes 30 minutes. If this takes 5 minutes, this takes 15 minutes. So if this takes a certain amount of time, this is going to take 3 times that time, whatever it is. So here we're going to go ahead and put x. Here we're going to put 3x. And again, we're going to set both of these equal to 1. And thus we form the fractional relationship that's going to help us figure out how much each machine would take if it worked individually. So we're going to go ahead and we're going to clear out the fractions like we did before. But in this case, the common denominator for x and 3x, the common denominator is going to be 3x. So we're going to multiply everything by 3x over 1. Let's go ahead and distribute that. We'll continue that down here. So that's going to be 3x over 1 times 1.5 over x plus 3x over 1 times 1.5 over 3x equals 3x over 1 times 1. And I certainly hope that the colors and distinguishing this is helping you out in solving these problems. So let's go ahead and see what happens with this now. So first, in the first part here, the x's are going to reduce, leaving me with 3 times 1.5, which will give you 4.5. Here, the 3x's cancel outright, leaving you with 1.5 over 1, or just 1.5. And here we're just left with 3x over 1 times 1, or just 3x. So here we have 4.5 plus 1.5. Well, 4.5 plus 1.5, that's 5. Half and a half is 1, so that's going to be 6, is equal to 3x. Now if I take both sides and divide by 3, I get x is equal to 2. So remember, we're talking about time and the number of minutes. So if we bring that back up here to get the answers that we're looking for, well, if 2 is equal to x, x is equal to 2. Here, this is going to be 3 times 2, or 6. And this is, after all, in minutes. Not 2 equals minutes, 2 minutes. So we have 6 minutes and 2 minutes. It says this machine is 3 times fast, so if I have this 2 and this is 3 times as slow, then this is going to be, hold on, takes 3 times as long. This will take 6 minutes, this takes 2. This, in fact, does check out. We're going to take a look at one more problem. Let's see how this is kind of put together. Okay, and we're going to take a look at question 15. So we'll take a look at question 15. In question 15, it reads as follows. The Ergo, I hate these names, the Ergo 750 can purify the air in a conference hall in 20 fewer minutes than it takes the Austin Healthmate 400 to do the same job. Together, the two machines can purify the air in the conference hall in 10.5 minutes. How long would it take each machine, working alone, to purify the air in the room? So we're talking what two machines here? We're talking the air. You can just tell mathematicians came up with these awful names. And then we have here the Austin. And the thing that makes it worse is that you can't even use, they both begin with A. So before we start putting this together, let's talk about the relationship between this here. The relationship that it characterizes in the problem is that the Ergo 750 can purify the air in 20 fewer minutes than this machine. So let's talk about this. If this can do this 20 minutes faster, if this is 60 minutes, this is 40 minutes. 20 minutes fewer than this. If this is 30 minutes, this is 10 minutes. So one way I can write this is say if this is x minutes, I have to take 20 from this, so it's going to be x minus 20. So the time it's going to take each machine is going to be determined with this. We know together that they do it in a combined time of 10.5 minutes. That's what's going to go, or 10.5 minutes, that's what's going to go on the top here. We know the time alone, that time is going to be an x and then x minus 20. So probably a few of you are already thinking, does it matter where I put the x and the x minus 20? The short answer to that is no. It makes no difference because you have the same numbers on top. That's not going to be true for some of the work we do later. We will have to pay closer attention to it. But for the purpose of this question, you're going to be fine. So we're going to go ahead and set that equal to 1 now. So we're going to go ahead and we're going to clear this out, which means when we multiply this through, this is going to get a little more complicated. But the technique is going to be roughly the same and should look familiar to the work we've done before. Because we have x and we have x minus 20, and we can't do a whole lot to simplify this, the best we can do is try to distribute x times x minus 20 over 1 through the whole thing. As you're going to see in a moment, this is going to get kind of big, and it's going to look a little cumbersome. The easier you can do the work you have when you simplify this, the easier overall the problem is going to get. So let's go ahead and distribute this work accordingly. So we have x times x minus 20 over 1 times 10.5 over x plus x times x minus 20 over 1 plus 10.5 over x minus 20 is going to equal, I should say equal x times x minus 20 over 1 times 1. And I leave it like so. So let's see what I can simplify. X here, x minus 20, x minus 20. Here, nothing simplifies. So this is going to give me 10.5 times x minus 20 plus 10.5 times x equals x times x minus 20. So the dreaded thing that's going to come out of this here is that we're going to likely have some type of quadratic equation that results. Now, if you want to perhaps even think about simplifying this a little further, before we do any further work, I'm going to distribute one more thing through here, 2. Just a nice, simple 2. And let's go ahead and see what happens, because having this fraction here just makes this problem ugly. You do not want to do this problem. Okay, so I'm going to multiply this by 2, distributed here, and distributed here. Multiplying 10.5 times 2, that gives me 21 times x minus 20 plus 21x equals 2x times x minus 20. And now let's go ahead and distribute this through here and 2x through here. So this is going to be 21x minus 420 plus 21x equals 2x squared minus 40. So we're going to go ahead as I'm going to bring this work over now to the next page. So we have from the previous page 21x minus 420 plus 21x equals 2x squared minus 40. Let's hope this problem turns out okay. And looking back at this now, I may have not needed to do that step after all, but we'll go ahead and work it out. So we see the 21x here, and then we see the 21x here. Just checking here. And I know it looks like it probably wasn't a bad idea to do this after all. And, I mean, it would have worked out, but we'll kind of simplify it later. So 21 plus 21, that's going to be 42x minus 420 equals 2x squared minus 40. So what I want to do, because I have an x squared term here, and I'm going to get a quadratic equation, is I want to get everything to one side and get it equal to 0. So I'm going to add 420 to both sides, and then I'm going to subtract 42 from both sides, 42x namely. And that's going to give me 0 is equal to 2x squared. And that's be what? Plus 380 minus 42x. I'm going to switch these around so I get 0 equals 2x squared minus 42x plus 380. One thing that may make this a little simpler to do is I'm going to go ahead and divide both sides by 2. Hence, I'm undoing when I multiply by 2. So that'll give me x squared minus 21x plus 190. So now I have x squared plus 21x, or minus 21x plus 190. So what I'm looking for are two numbers that multiply to 190, but that add to negative 21. So two numbers that add to positive 190, but add to negative 21. So let's see here. If I'm solving this, that means I need two numbers that are going to have a, let's say, it looks like both of these numbers are going to appear to be negative because I have a positive product but a negative sum. So if that's the case, then see two numbers that add let's see, two numbers that multiply to 190. So let's go ahead and let's take a look at this. So we have 1 times 190, 2 times 95, 3 won't work, 4 doesn't work, 5 times 48, 6, no, 6 doesn't work, 7 doesn't work, 8 doesn't work, 10 times 19. Is there anything else? 12? Save this question. I'm going to go ahead and go over this question number 15 in class. So I'm going to tell you to ignore it, but I promise to go over this one in class. This is going to wrap up the first of 2 lessons in section 7.7. The other part of 7.7 is going to go over ratios. Thank you for watching.